Hi guys, Kaya had some questions about the first 4 questions of the relative dating castle learning, so let's take a look at this. This is question 1 here. And question 1 is, let me get the screen. So as you can see when you look at this one, you've got the fault and then behind, and the intrusion is in front. So in order for the fault to have happened, E, F, and G, and D all had to be there. You can't crack something, and a fault is essentially a crack. You can't crack something that doesn't exist. So the answer has to be 3, because E and F had to be there in order for E and F to break. Hope that makes sense. Number 2, let's go to number 2 here. Okay, so number 2 has the good old-fashioned unconformity that I hope you remember. And an unconformity is like as if you were reading a book, and when you were reading the book, you read one page and it said, and they went for a walk on the beach and fell in love. And then the next page was, they got a divorce. Well, there'd be a piece missing of that book. There would be some pages torn out. So what you see here is essentially pages torn out. So you've got this story, and then this is missing. Sorry. Yeah, so you've got this here, and then this is something that's missing, that wiggly line. There was a time period of erosion and then deposition, and then this got deposited on top. So that wiggly line represents, you could see that something is missing. There was something there that's not there anymore. Just like the piece of the book. It's like, okay, so that is a period of weathering and erosion, breaking it down and washing it away. So the fold that you see under that unconformity, that's a period of uplift. Remember when we took the 2 pieces of paper and pushed them together and then they folded because of plate tectonics? So it's uplift, and then you have your weathering and erosion, and subsidence is the last thing, and that just kind of, that's that Silurian layer. Subsidence means it kind of got deposited and then like settled in. Subsidence, it subsided, settled in. Okay, let's look at number 3. I hope this is helping. Okay, so number 3 is to rate them oldest to youngest. And here we are, we have it. So what can you see is the oldest? You can see that the brown areas used to match up to each other, and those polka dot areas used to match up to each other, but then they got faulted. So you would see that rock layer C is the oldest because that was on the bottom, and then there was B, and then C and B cracked, faulted, and the D is pointing to the fault, and then on top you have rock layer A. And that's just a matter of putting the letters in over there, oldest to youngest. And then number 4 is just basically a real life picture of what you had in number 1. So whatever cuts in front is younger, right? So let me just do this quick little experiment here. I've got my postcard, and I'm going to drop this mug on top. Well, the mug cuts in front of the postcard. What's older? What was deposited first? The postcard. And then the mug cuts in front. It was deposited second. It's younger. So that's what you have here. You've got, as you can see, C had to be there. So in order for, these are 2 magma intrusions. These are 2 times that magma came through. So B cuts in front of A. So which one's older? You would have to have A be older. So C is the parent rock, which you call it. It was there first. And then you could see that A is a piece of hot magma that intruded in, and then B is another piece of hot magma that intruded after. So you had a rock, and then a stream of magma came in, found little cracks in the rock and came in, making A, and then B came in another time. I hope that helps, Kaya, and anybody else who had the same question. All right, bye-bye.